right, Riley is back to go over geometric sequences. So suppose somebody got these golf scores and they're getting progressively worse as they play. So if their scores are -8, sorry, so -8, 4, -2, then my common ratio is what's changing? What's the ratio between these? So I would divide by a -2 each time, but I want to put that in terms of multiplication. So r is going to be equal to -1/2. So that's my common ratio since it's a geometric sequence, and my terms are differing in terms of what ratio. So with multiplication, what is their scores in the next 3 games? So -8, -4, -2. So in the next 3 games, I'm going to follow this pattern. So -2 times a -1/2 is going to give us 1. 1 times a -1/2 is going to give us -1/2. And -1/2 times a -1/2 is going to give us 1/4. Okay, so part C, write a rule. So my rule for geometric sequences, so I'm just going to say a function in terms of g, is always take the first term, multiply that by the common ratio to the power of n minus 1. So a rule for the nth term would be take the first term, which is -8. Okay, my common ratio is -1/2 to the power of n minus 1. So since it's a function, I'm going to keep it in terms of n. So we'll box that up. All right, and D, now I want to know what is the score in the 9th game. So now my function is in terms of 9. So g of 9 equals, I'm just going to take that same function, and then this time n is equal to 9, so n minus 1 is equal to 8. And because we don't have a calculator, we're just going to leave it like that. All right, so then we're going to go to the next problems. So using this box or square, let A, so first term is equal to -1/2. So, equal to 1/2. So how do I get from 1/2 to 1/4? I'm going to multiply by 1/2. So r is equal to 1/2. All right, you are so bored at home, you decide to record the data of you bouncing a bouncy ball, and this is what your graph looks like. Write an equation to describe its bounce. So again, this is geometric. Okay, so first term times the ratio n minus 1. All right, so hint, figure out the sequence. So I'm going to write my term numbers here, and I'm going to write their height. So at 0, it's at 20. At 1, it's at 15. We can't really see it too very well, but I could figure out what my common ratio is by doing this. So I got to 15 by multiplying 20 by something. So solving for r, okay, so if I simplify that, r equals 3/4. So I know that r is equal to 3/4. And then I'm going to use my formula. So this means my first term. So this is my first term. So my first term is 15, okay, times my common ratio, and then n minus 1. So when you have a geometric sequence, you don't actually start at 0. You always start at first term because sequence is really just a list of numbers, and a list starts at 1. All right, that's it for this section. Bye.